Sometimes a hypothesis test related to the mean of a sample needs to be conducted, but the population standard deviation is not known. In this case, the sample standard deviation can be used as an estimate for the population standard deviation. The test statistic is calculated using a similar formula as when the population standard deviation is known, but using the sample standard deviation S instead of the population standard deviation sigma. The statistic is the sample mean x bar minus the hypothesized mean mu sub 0, all divided by the sample standard deviation over the square root of the sample size n. When the population standard deviation is known, the statistic follows a standard normal distribution. However, using the sample standard deviation as an estimate introduces more variability into the statistic, and it follows a student t-distribution. There are infinitely many such distributions depending on the size of the sample. The distribution has a parameter called the degrees of freedom, which equals n minus 1. As the degrees of freedom get larger, the student t-distribution gets closer to the standard normal distribution. Since the distribution is different, a different symbol, t sub 0, is used for the test statistic. Once the degrees of freedom for the distribution, the test statistic, and the level of significance are known, the conclusion for the test statistic can be determined. This can be done using a p-value approach, a critical value approach, or a confidence interval approach. Here we will consider the critical value approach. Let's look at a problem. It is reported that an average adult sleeps for 7 hours. A sleep study was performed with 25 adults giving a mean of 7.23 hours and a standard deviation of 0.6 hours of sleep. At the 5% significance level, is there enough evidence to say that the average sleep time is greater than 7 hours? To start, name the hypotheses. The null hypothesis is that the population mean is 7 hours. The alternative hypothesis is that the population mean is greater than 7 hours. Next, identify the significance level, alpha, which is given in the problem statement as 0.05. Now we can calculate the test statistic. The formula requires the sample mean x bar, which is 7.23. The sample standard deviation S, which is 0.6. The hypothesized population mean mu sub 0, which is 7, and the sample size n, which is 25. Now we can use the formula for the test statistic with the known values. Substitute the values into the formula, and then calculate the result to get 1.917 when rounded to 3 decimal places. To use the critical value approach, we need to determine the rejection region. Since the alternative hypothesis is mu is greater than 7, this is a right-tailed test with a single rejection region t greater than t sub alpha. Using the given level of significance, the critical value is t sub 0.05. The degrees of freedom are n minus 1, which is 24. Now we can use technology or a student t-table to determine the t-score that has a right tail area of 0.05 for a distribution with 24 degrees of freedom. This gives the rejection region t is greater than 1.711. Now we are ready to determine the conclusion for the hypothesis test. The test statistic is 1.917, the critical value is 1.711, and the rejection region is t is greater than t sub 0.05. Therefore, we should reject the null hypothesis. In the context of the given problem, that means there is sufficient evidence to support the claim that the mean sleep time for adults is greater than 7 hours.